Hello everyone and welcome to another pseudo live video. This video will of course have little editing and low effort, but I just want to make a lot of content because I just have a ton of projects to do and I really want to show them on YouTube. I know a lot of people really want to see the Z80 video, but I just don't have the energy to make another very long video going into the technical details of that Z80 computer. So today what we'll be looking at is this. This is what I call the Frankenstein 286. It is itself an ASD premium 286 computer, but what is special about it is that it's made of all Chinese eBay parts. The original chassis come with a clone board, and it's not even a clone of the AST motherboard. It's a generic AT style 286 motherboard because obviously there was a fire, or there might be just a flash, a cap exploding, I don't know, but it looks like a fire to me. So I went online and amazingly found original motherboard without anything, bought it as is, bought a graphics card for this computer, and most critically I also bought the RAM expansion card for this computer because, as crazy as this sounds, ASD don't equip this motherboard with any onboard RAM. I don't know what's the decision behind this, but obviously that's what they chose. They chose to include onboard floppy controllers, but not RAM. So before we open this up, let's just fire this computer up and test it. But before we do that, I will just remove this compact monitor. It just feels out of place. Okay, we are back with the ASD monitor. So let's just fire it up. The computer is now equipped with a generic TVGA 9000i graphics card because the original card that comes with this machine should be EGA, but I did have one of those ASD branded EGA cards, but I don't know whether they work and they are not essential for this computer to boot up. So I just decided to not include them. Monitor on, and here we go. Oh, a beep. That's not good. 4, 3, 4, 5. Yeah, 5 beeps. 5 beeps. And more beep. Yeah, 5 beep. Exactly as I tested off camera before. Let's see if it's consistent. Power it up again. 1 long beep, 1 beep, 2, 3, 4, 5. 1 long beep and 5 short beep, and let's check what's the error corresponding to that beep code. Okay, after a little bit of searching, I determined that the problem is actually the RAM board that I bought separately, also as is, and that's what I will replace next. Because I've got a few working machines that have those RAM boards, and I can confirm that they have 1 megabyte or 1.5 or 2 megabytes of working RAM. Opening the machine up reveals a few components inside. Under here is a hard drive. It's an original ASD part because I can see the ASD part number. The power supply is probably original because there's an Aztec label on it, and I found Aztec power supplies on multiple ASD computers because I think they're just ASD egg. Definitely not the real reason. I don't know whether the floppy drives are original, but the configuration is. I think I swapped them out for floppy drives from other ASD computers, but I did remember that these floppy drives from the machine with incorrect motherboard when it originally arrived. The floppy disk did not work, but I also remember fixing those, so I might just put them back in. So although this is a Frankenstein computer, this part is the part that's not changed. This is the original part, along with the chassis and everything else. They are from completely different sources, from completely different people, and all sold as is. And what we have identified here is it probably has faulty RAM, but it also probably has working motherboard, which is a good news. I think we should also power it on while it's not covered. I think we should also power it on with its cover off, and let's just do it. You can see I put a postcard in there. It shows 15, 14. You cannot see that on camera because of the refresh rate thing, but it's 15, 14, and I guess the number is actually 15 because it's a double-digit postcard. It's not designed for these computers, but it's showing number in order. Of course, those are hex numbers, but it's showing numbers in ascending order, which means that this machine does have a postcode, which is again good news, which also indicates that the motherboard and BIOS are working. Okay, here's another RAM card. It's called the AST Fast RAM, and this is trademarked. So I don't know what's the deal with this card here, because this card really makes no sense to me, because here's a 16-bit ISA slot, and as far as I can tell, this connector here is also 16-bit, and that's no surprise because the 286 uses a 16-bit data bus, so there's no point going up to like 32-bit unless you implement some like SRAM cache on the board. But obviously that's not what's happening here, because from what I can tell, this board works with only 16 like RAM chips installed. If you ignore the parity, if you want parity, you actually need 18. But if this is like a combined 32-bit bus, you would need at least 32 chips installed. And if that is the case, this board would come with 32 RAM chips pre-installed. But that's not the case. There were only 18 chips installed, and these are all sockets. However, a third of the sockets are populated, giving it 1 megabyte of RAM with parity. So what I can think about this board is that this connector here actually works at the CPU's frequency, which gives it 0 wait state. Here we can actually see that the CPU go up to 10 megahertz, while the ISA bus on this side works at 8.33 megahertz, which is like 8.33 megahertz. So that may give it a little speed boost because it doesn't need to insert any wait states. However, this CPU also works at 8 and 6 megahertz, and if this part of the bus is clocked at the same frequency as the CPU, it will work slower at 6 megahertz. However, I would presume that if the CPU is running at 6 megahertz, the ISA bus would also be underclocked to 6 megahertz to avoid running an asynchronous clock. Again, however, the ISA bus is actually capable of running at 10 megahertz. There are like very few devices that won't work at 10 megahertz, and some will even work at 12 or even 12.5 megahertz. And if a device cannot work at those frequencies, we'll automatically insert a wait state to kind of like hold the bus to inform the motherboard to essentially underclock the bus just for that device. And the only situation where, as far as I understand about the ISA bus, that this whole system won't work is that the ISA bus is so overclocked that like bus transaction or bus read-write operation is finished before the device can even assert the wait signal, and that would require you clocking the ISA bus up to like 16 or 20 megahertz, some crazy stuff. And those just won't happen on a system with a 10 megahertz CPU. So again, I don't really know what's the deal here, but I guess this is the way that AST people decide to do it, and they even went as far as putting no RAM on the motherboard and putting this whole bunch of mess here. And I guess this is one of the reasons why they don't put it on the motherboard, because these are all discrete TTL chips and they probably just don't find enough space on the motherboard. So I can understand why. And I mean, if they can consolidate all of these into a single VLSI chip, they would probably just put things on the motherboard. But they probably did not have an integrated circuit design team, probably. So they did it this way and they made it a fast RAM board. And they think that there are enough reasons for them to do so. Obviously, this makes the RAM faster, right? So with the magic of video editing, I'll just insert that board. Okay, the new board is in. Yeah, it might not be very obvious on camera, but they all look the same. But if the problem is really the RAM, this should just work. Great news, no beep codes. Yes! Got something here. CMOS battery, CMOS checksum, configuration. All failed, but that's as expected. Nice. Now it needs a CMOS battery, but I can fix that. Memory size error. Of course, because for whatever reason, the AST Premium 286 stores its RAM size in the CMOS, in the non-volatile storage space, and Control Alt ESC for setup. Okay. Yep, all as expected. VGA card, speed 10 megahertz. Of course, there's no point in adjusting these for now because it will need a CMOS battery, which it doesn't have. But this is something great. I've never seen this BIOS screen showing up on this particular machine. So it is a great achievement. And that concludes this video. I want to split up my repair videos into several parts so that I can just pump out more videos more frequently. And for those who just want to see another Z80 update, I would say that the BIOS of the Z80 machine, which I call the monitor kernel application, is now under development. That is the soul of the machine, which enables all the functionalities that I talk about in those earlier videos. So that's it for this video, and bye bye.